Yo, testing 123, testing 123, testing. Sorry about the wait, guys. They're ready to come back online if I'm not mistaken. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. Yo, we're doing programming, guys. You guys know the deal. You guys know the deal. This is our kind of a new show on the channel here. We're doing some intro to Python. It's kind of like Python tutorials, examples, very basic stuff for total beginners to programming. People that never programmed before in their lives. I'm trying to make it approachable. And part of that means using Notepad, guys. I apologize if you guys are experienced programmers and this is hideous. Some of you newbies might not have access or experience with access to or experience with a IDE, which is like an environment for programming, and you don't really need that though. I want to prove that you can do it with just Notepad. It's very simple, but yeah, it's a little bit hard on the eyes. I apologize. Starting on next Friday, we're going to be using an IDE called Idle, which comes with Python. This week is our final week here playing around with Notepad though. Once again, guys, as usual, when we program, you're enjoying the music of my friend Aubdat. That's A-U-B-D-A-T. If I can go over here and show you his Bandcamp page. That's A-U-B-D-A-T, Aubdat. Very cool guy. His music is sort of like ambient, a little bit droning, a little bit resonant sometimes. It's sort of avant-garde. I know it's kind of an overused, trite turn of phrase, but a little bit avant-garde. It's kind of cool. I find it's good for focusing, good for doing homework and programming, that kind of thing. And for a stream like this where it's just be totally silent otherwise, I think it's kind of cool to have in the background. What's up, here goes? Yes! Yes! That's the best VIA yet. I don't know why I didn't think of that one sooner. So godlike. Welcome aboard, here goes. Always brightening my day with that VIA first thing. Okay, so I'm going to close this little Aubdat video, Aubdat tab. But yes, go visit him. Aubdat, A-U-B-D-A-T. .bandcamp.com, aubdat.bandcamp.com, Aubdat. Go check them out. It's all for free, guys. Free music. It's available in FLAC format if you like lossless stuff. Also MP3, of course, and other formats if it suits your fancy. Okay, so let's go back to our Notepad file here, guys. In fact, I forgot to launch CMD. Let's do that. Command prompt. Shrink it down. Yes. Doesn't feel like a Friday to me, huh? What does that mean? Is that a bad thing? Friday usually feel pretty good, right? Unless it feels like a Saturday, that's the best. Maybe we have 2 Saturdays this week, huh? I think Saturday is the best day of the week because that means you have another day even after that for the weekend. Alright. Just kind of moving things around, guys. I apologize. Alright, so let's go to the correct folder here. I want to go to CD, its current directory, or change directory. CD to my Learning Python folder. Okay, and now in here I've got this Adventure Day 3, right? So let's run it py, that's py, so command run Python, Adventure Day 3.py. Now use a .py extension there at the end of your file name to make sure that Windows knows the Python file. Boom. Feels like a Saturday. Nice. Nice. Nothing wrong with that. Okay, so it starts off, here's our game, guys. It's a little text-based adventure game in the spirit of Zork. If you guys haven't played Zork, you're probably too young to know what the hell that is. It's like a text-based adventure game. You kind of walk around, you give the game commands, you walk around and explore, you get some items, you solve puzzles. Think of it sort of like, Sam and Max or a typical point-and-click adventure game, but without the pointing and the clicking. It's just you have to get items and use them and solve little riddles and stuff, but it's all textual. Here goes, I played Zork on Call of Duty Black Ops 1. What do you mean by that, here goes? I never played Call of Duty Black Ops 1, I don't know what you're talking about. So what do I want? It says I'm in a cave, what do I want to do? I want to do a dance. I know the commands, right? From a break dance, nice. I want to look around. Okay, the cave is dank and there's a treasure chest. There's also a door. There's also a torch. All right, let's grab this torch. So get the torch is the command we programmed in. All right, we got the torch now. Let's look around again. So look around now. It says there's an empty spot where the torch was. So as you can see, guys, the game is interactive. It does change. The environment changes based on what we do, right? And for novice programmers, it's pretty cool, I feel like. So what do I want to do now? I want to open the chest. Let's open the door first, right? Open the door. Okay, the door is locked, dang it. Okay, well, let's open the chest. Okay, so you open the chest, there's a key inside. Cool, let's get the key. Got the key, let's open the door now. Okay, the door's still locked. Let's unlock the door. Okay, use the key to unlock the door. Nice, let's open the door now. Okay, the door is open now, but we can't really go through it yet. We have no way to go through the door yet. But we can leave the cave now. That ends the game. Boom, game over. Let's see here. There's a computer terminal that has Zork on it. You can play the whole ass game, huh? Put your dick in the spot. Put dick in spot. That's pretty cool. So there's a computer terminal that has Zork on it in Call of Duty Black Ops 1. Huh? That's pretty funny. I've never completed Zork, but it is an inspiration for me, among other text-based games. Mostly I grew up playing textual MUDs online, like multiplayer textual adventure games. kind of like an MMO. Those are really cool to me. Okay, so let's see how this code works, right? First of all, we're going to gloss over this real quick, but we have a bunch of functions, right? We actually have one function we've defined per command in the game. That's how we've done it so far. One function per command. As you can see, every function does something cool, like this look around function. It does that little, prints off the cave is dank, the treasure chest, right? There's also a door, etc., etc. That's how that works. Do a dance as a function, very simple one. Open the chest, get the key, etc. Leave the cave, get the torch, open the door, unlock the door, all that good stuff. Then if we define all of our functions, we define some variables to save the state of the game. Right? So as the player is making progress, we are saving their progress in these variables. What we have here is we have a chest is open flag. Right? The game starts off, chest is open is false. But as you can imagine, later in the game you can change that flag to chest is open is true. Right? Door is unlocked starts off false. So the door is locked, right? The door unlocked is false. A door is open is false. So right now the door is closed when the game starts off. The player inventory starts off as an empty list. So it's a list of stuff, and right now there's nothing in that list. So it's an empty inventory when the game starts off. And adventure is ongoing is true. When you complete the game, that turns to false. So once you leave the cave, the adventure is ongoing becomes false. Then we just simply print off a little statement here for the player to introduce them to the game. Right? These are all of our game state right now. It's a very simple game, very simple game state. We save it across, like 5 variables. Right? So it starts off with you are in a cave. And then we start asking the player what they want to do. Now here's where the complexity comes into the program. Right? And even then it's not all that complex. We have a while loop. So when we say a while loop, a program always reads from top to bottom. Right? It starts off up here, and it starts defining these functions, and then it gets down to here, define some variables to store the game state in. And then we enter this while loop. Now this while loop is interesting because unlike most other bits of the code, it does not read top to bottom. It actually reads top to bottom, back to the top, to the bottom, back. It just loops over itself over and over and over again, right? And it starts off asking the player what they want to do. Right? There's a little function here, input. It's a built-in function in Python, input. And you can get some input from the player, some textual input. And we save that data that they enter into this player command variable. And then we start testing that variable. I say, hey, listen, what have you typed in, right? Player command. Is that equal to look around? If so, then run look around function. But if that's not the case, then did you type in do a dance? Right? What we're asking here is the player's command equivalent to this textual string? Right? If the player command is equivalent to this textual string, then run this function. Elif means otherwise if the player command is equal to open the chest, then run this function. Right? And so on and so forth, all the way through every command in the game. Right? We have this many commands in the game, that many functions. It just matches the command to the function very basically. Here it goes, says, when's a pro wrestling text-only game? Here goes. If you'll help me with that, we can do that some other time in the near future. But you have to help me, because I don't know anything about pro wrestling. So we actually, after we finish testing the commands, then we print off a blank line here at the very end. That way it makes it a little bit easier to read. Go look at our code here. As you can see here, we enter a command, right here. There's our command, open the door. And then it prints off whatever the response was. The door is locked, and then we get a blank line. That makes it a bit easier to read, I feel like, right? Rather than having to just be like one big cluster of text. Okay, then once you escape the loop, right, if the loop ever ends, then it prints off game over. As you can see here, the loop did end. It says game over. It's when we left the cave, right? We left the cave, walk out of the cave, game over. Here's how we escape the loop, guys. The loop only keeps running while adventure is ongoing is true. Right? Whenever you have a while statement, it's followed by a condition to keep on looping. And the condition here is that this has to be true. Adventure is ongoing. And adventure is ongoing is true. Right? Awesome. Except right here, if you try and leave the cave, then your adventure is ongoing value might change. In a case it does, right? It changes to false if you leave the cave successfully. So once this changes to false, then this flag is no longer true here. We stop looping. We get down here to print game over. Then the game ends because there's no more commands down here. Right? That's the end of our program. So once there's no more commands left, Python exits. As you can see, we are back on the Windows command prompt here. It could be a lot of fun. Here goes. We could have like a fighting, like a text-based fighting game. Maybe implement like some kind of submission system, something like that. Maybe make it go online at some point. That could be cool. It'd be really cool. Okay, so now we know how the program works right now, more or less, right? We know that we ask the player for some input, then we match that input to a function, and every function has a different argument it might take, so it might need some kind of information to work correctly, right? For instance, look around has to know the player's inventory in order to tell them whether or not there's a torch on the ground. If the player has a torch, then the torch is not on the ground, right? Likewise, open the chest. Right? Open the chest. It has to know if the chest is already open. So we can say, hey, listen, bud, the chest is already open. It has to know if the player has the key. If the player has the key, you can say there's no key in the chest. Right? And then that's true of, get the key as well. It has to know if the chest is open. It has to know if the player has the key already. Adventure's ongoing. You can only leave the cave if you have the key. So it has to know the player inventory. So basically, we explained this in the last few episodes. When you define a function, you can define it to require an argument. That's what it's called. Let's go up here to leave the cave, for instance, right? So leave the cave, you can only leave the cave and end the game if you have the key. Right? That's our rule. So you can feed this function, leave the cave, an argument, player inventory. That means that you can feed it some data that it needs in order to operate correctly. So basically, you can't leave the cave unless you have the key. So it has to know the player's inventory. And here it uses it. It says, hey, listen, if key is in the player inventory, then they can leave, right? They walk out of the cave, Adventure's Ongoing becomes false. Otherwise, else means otherwise. So if the key is not in the player inventory, then print off, aren't you forgetting something? And then Adventure's Ongoing is still true. Right, so you're not allowed to leave the cave. And that's true of any function here that requires an argument. All these functions here, they require some data to work, and that's true of pretty much any function. You're not going to have a function very often that requires no input. In fact, you have this do a dance function here. Do a dance function, it has no argument. It requires no data. That's because all it does is print off one line of text. Pretty pointless. But we defined this early on as a way to kind of explain how functions work on a very basic level. Very rarely will you have a function that just runs some code. I shouldn't say very rarely. It's just not as common as needing to have arguments, because usually a function will take some data in and then spit some data back out using return here. When you have return at the end of your function, or anywhere in your function, it'll cause the function to end when it runs, for one thing. It'll always cause the function to end when it runs. But it will spit out some data. Return means like spit out this data. So we return whether or not the chest is open here. And then we can save that return value into a variable. So here you see chest is open equals open the chest. Right? So basically what we're trying to say is this value here, chest is open, we're changing its value to whatever data is returned by open the chest. So open the chest can return true or false, and then save that to this value here, chest is open. Cool beans. So today, guys, I want to take a look at ways we can use dictionaries to make our program way simpler. Now, right now our program is, to be fair, pretty simple. It's pretty simple for a game, and it works pretty well, I think. We have these functions on top, and we match those functions down here to some, commands, and then there you go. Bob's your uncle. It's done. There you go. But what's interesting is that as we add more commands to our game, then this elif tree is going to keep on growing and growing and growing and growing. And every function requires different arguments, right? It's going to be a lot to keep track of eventually, right? And some of them, not all of them, but some of them also return a value that we have to save as the player's progress. Right? Adventure's Ongoing has to get saved right there. The chest is open, it's saved right there. Get the key doesn't need to return value. Right? Get the key doesn't actually save anything because the player inventory is being manipulated directly. We supplied this function with the player inventory, and it can use that to see if they have the key or not. But also we can use that to add the key to the inventory. So we don't actually have to do anything here. We're not saving any values here. What I want to do is I want to, first of all, condense all of our, well, let me put it this way. I want to make sure that all of our functions take the same arguments. That way we can hot swap them, right? I'll show you what that means later. But basically what I'm talking about is I want to unify the way all the functions work to make them easier to understand. Right now it's kind of whack that every function requires different kinds of data, and some of them return data and some don't. So if we can make all the functions behave the same, that is to say, they spit the same data out and take the same data in, then it becomes much easier to add more and more functions over time because it's less to keep track of as a programmer, right? That's one thing I want to do. And by virtue of doing that, we're actually going to also simplify our logical tree here, this tree of logic. If this, do this. L if that, do that. L if that, do that. We actually simplify this by quite a lot by unifying things, by making things more standard. That's true of a lot of things in programming, guys. As you become stronger programmers, you're going to notice that if you can standardize your code, then it becomes easier to extend it. You can add more easier, right? You can keep on adding to your code over and over again if there is sort of like a cookie cutter that you can use to manufacture or mass produce these kind of functions. Hey, what's up, Zanzu? He said, poggers. Oh, right. Feels bad, man. Please, what do you mean, feels bad, man, Zanzu? You're allowed to say poggers. Not sure what poggers means, but you're allowed to say that. Welcome aboard, dude. Pleasure having you, homeboy. Okay, so we have all these functions that take different stuff. Here's what we're going to do, guys. We're going to use a dictionary to unify the way they take in and spit out their data. But first of all, what is a dictionary? Now, we talked about this last time briefly. I'm going to very briefly again go over it because it is, for a beginner, it's kind of hard to understand. Let's save this as, a dictionary example, 2 or whatever. I already did a few of these. And let's make our dictionary. So we're going to make a new variable here called myDict. It's a dictionary. And we're going to supply it. It's going to be an empty dictionary, right? So the curly braces here make a dictionary, and with nothing in between, it's an empty dictionary. Right? So let's put some things in the dictionary. Huh? Let's put in some keys, like Zanzu. Right? That's going to be we'll map that to awesome, because Zanzu is awesome. Right? So basically, a dictionary is kind of like a list. Except that instead of it being just a list of things, like a list of inventory items or whatever, you got a key, you got a torch. Instead, a dictionary is what's called a map. So it will map one piece of data to be associated with a second piece of data. So here we're using the key Zanzu to map to the value awesome. So Zanzu and awesome are now associated with each other. Right? We can do the same thing for here goes. Right? We'll do like here goes nothing 9. He's all right. He's kind of, he's all right. So we have these two values now, awesome and all right, in our dictionary, and their keys are Zanzu, and here goes, I'm just going to capitalize Zanzu, and here goes nothing. That's our dictionary now. So we kind of have these values mapped to these keys, and we can use that in kind of cool ways. For instance, we can, we can say print off. Zanzu is plus myDict Zanzu. Right, let's see what happens here. Let's run this code. Let's run pi dictionary example 2.py. So it prints off Zanzu is awesome. What's cool about a dictionary, guys, is that you can actually get the data out of a dictionary by supplying the dictionary's name, myDict, and some square brackets. I don't know why they didn't use curly brackets, but it's square brackets. And then you put between the square brackets the key of the data you want. So I wanted to get awesome out of here, right? I want to get awesome out of here. So I used the key, Zanzu, that gets me back awesome, because they're associated. Right? And we can do the same thing with here goes nothing, right? Here goes nothing 9 is, right, we want all right. So we can say here goes nothing 9. Because myDict, the value at here goes nothing 9 is all right. Right? You feed in the key, and you get out the value. Right? You feed in the key, you get out the value. Let's run this code. That's very basically how dictionaries work. See, here goes nothing is all right. But also you can add more stuff to a dictionary. Once you've made it, you can actually extend it. So you can say like, myDict, I want to put something in that, Vencabot. And we can make this be like, a beautiful boy. Of course he is. So you have myDict Vencabot, and we're assigning this key a new value. We're assigning this key a value. Now it's a beautiful boy. So now we can say print Vencabot is plus my dict Vencabot. So now we're saying, get this data, this value, that's currently at this key of Vencabot. So we know that at Vencabot is a beautiful boy. Let's see if that works. Wow. This thing is such a flatterer, dude. This program, holy shit. Back off. Get off my dick. You don't know me like that. Okay, so we know that you can create a dictionary with keys and values already inside of it. And we know you can add new things to the dictionary, right? By using a simple assignment. You can say my dict, then supply the key, and then a simple assignment operator equals, and then give it some kind of data to associate with Vencabot, right? And we know it works right there. So before really on this channel, we've only ever used dictionaries once in a competent way, which has been the Pokemon example, but we're not going to talk about that right now. That was our last season. But up to this point, in terms of examples, we've only used very simple, stupid examples, like, associating a name with a trait, right? Just kind of try to drive into your mind what a dictionary is and why it works the way that it does. So now let's actually apply this in a way that's kind of meaningful. Let's open up our adventure game. That's day 3 right now. Okay, so here's what I'm going to do, guys. Instead of supplying individual progress variables, like whether or not the chest is open or whether or not the door is unlocked, instead of supplying those to these functions, I'm going to supply them a uniform dictionary. So from now on, every function that we make that actually advances the game at all is going to take the same exact argument, which is what I'm going to call game state. So let's make a new variable here. I'm going to call it game state. Right? And so instead of using these simple flags, chest is open, door is unlocked, I'm going to actually use keys and values in a dictionary. So let's just adapt them, right? So we're going to say our first key is a string. Chest is open. And its value is going to be false. Right? So we're associating this key, chest is open, with its value, false. Do the same thing for our other variables. Door is unlocked is now a key in our dictionary. We're going to give it the value of false. Okay. Then we're going to say, door is open is a string. Give it the value of false. We're making another string here. Player inventory. Give that the value of an empty list, just like before. And let's actually, because this is getting a very long line, let's use a hanging indent. So in Python, if a line's getting too long for you and you have a list or a dictionary, you can actually go after the very first character of the dictionary, this curly bracket, and then break the line, boom, with the enter key, and then do 8 spaces. 1, 2, 3, 4, 1, 2, 3, 4. It's called a hanging indent. Once you've done that, you can actually do this. You can just keep breaking the line. 1, 2, 3, 4, 1, 2, 3, 4. There you go. So now we have our, we're not scrolling to the right all the time. Let's add some more stuff. We actually have to add adventures ongoing, right? So we can do a string. Adventure is ongoing, and that's going to be true. Let's break this line too. 1, 2, 3, 4, 1, 2, 3, 4. Okay, so we got our hanging indent there. We have our game state variable. So now we've made our previous variables obsolete. Instead of being traditional variables, we're using a dictionary instead. That stores the game state, the entire game state. Let's just get rid of those. We don't need those anymore. All right, these should all be double spaced. Not that it's super important, but it's what's called PEP8. We'll talk about that later. So let's just add some double spaces here after the functions. Shouldn't just be single spaces. I'm the fool I never thought I was. Okay, so now we have this game state variable that stores the entire game state in one variable. And what's kind of cool about that is that now, instead of having every function require its own argument, right, we can just apply it the entire game state and let it do whatever it wants to do. So let's just get rid of the player inventory here, for instance, right, and feed it instead a game state. And now we can say, if not torch in player inventory, it doesn't have that variable anymore, right? We don't know what the player inventory is. Unless we can do this, we can say, we want to check the game state we were given and check the player inventory of that game state, right? So we've kind of changed the way our program works now. Instead of supplying our arguments directly to the function. We are supplying this game state to the function, and the function can check the game state for whatever it wants. All right, so there you go. So we're feeding the game state. Now it says, is the torch in the game state's inventory? And if so, print off there's also torch or whatever. It's whatever now. And same for every function, including do a dance. Now, do a dance doesn't require any arguments, right? We see that right here. It doesn't need any arguments. However, we mentioned before that we want to make our functions uniform. We want to make them all the same so they can be easily manufactured in the future, right? If we can make them all behave sort of similarly, it becomes much easier to produce them in the future if we have a standard. So we're going to give this the same variable, the same argument, game state. Everything gets game state now. Every single function now just takes the game state. So they're all the same. And now we can't really check if chest is open, right? We don't know this variable anymore. We don't know what the hell chest is open is anymore. But we can supply the game state. If not game state, chest is open, because it has that has a key by that name. Likewise, player inventory. Let's check the game state at the key player inventory. That's where the inventory is, right? So there you go. All right. Likewise here, supply the game state. And then now we don't have these variables anymore, like chest is open. We have game state. Chest is open. In key, not in game state. Player inventory. Kind of a long line there. We can break that later. I'll show you how that's done. If game state, chest is open. And key in game state, player inventory. There you go. Leave the cave. It's going to not take the inventory anymore, right? Every function takes the game state now. It's just a dictionary that has everything you need to know in there. All right, so we have game state, player inventory. Okay. Get the torch. Doesn't need to take the inventory anymore. Now it just takes the game state. Everything takes the game state. Now it knows everything has to know about anything. Game state, player inventory. Okay. Then here we actually append the torch to the player inventory. Right, so we have to say game state, player inventory, append. So we're adding the torch to the inventory. Right there. Okay. We have a get the torch. We have a open the door. Now it takes it to the game state. It doesn't need any special variables for arguments at all. It just takes the whole game state. Game state, is the door locked? I don't know. Right. Likewise here, if not a game state, door is open. Okay. All right, here we have these random arguments we need. Instead, we're going to replace that with the whole game state. So now it knows everything, not just certain things, which can be a danger. We'll talk more about why that's dangerous, but it's also convenient. There's always a balance to strike between doing something kind of dangerous and doing something kind of convenient. We'll talk about why that is later on. Supply the whole game state. We're going to check the inventory this way now. Okay, so there you go. Also, as you look down here, you'll see that these functions, right, for instance right here, right, they return a value. Right? They return a value into whether or not that thing is open or not. Let's just, for now, let's change these. We're not using chest is open anymore, right? We're not using adventures ongoing. We're using a game state now. So we have to fix this too right here, right? We have to check the game state. If game state adventures ongoing is true, then keep on looping. Likewise here, we can say just update the game state, chest is open. With the return value, open the chest. And we'll actually get rid of these later, but for now we're going to just simply update our code to replace the old variable names with the new game state. Okay. Game state door is open. Is the value of, open the door wherever it returns. Likewise, game state door is locked. Door is unlocked, excuse me. Okay. And now I have to adjust all these function calls so they all take the same argument, right? It still says here, look around takes the player inventory. Open the chest still takes chest is open and player inventory, right? We're going to give them all the same argument now. They're all just taking the game state. Simple. Even do a dance takes the game state now, even though it doesn't need it. Everything, all the functions take the game state. That way we can manufacture these easier in the future. We know that what they take, they all take the same thing. Okay. Okay, we all use the game state variable. This dictionary that has all the progress the player has made in it. Alright, give them all the game state. Okay, let's see if this program works now. I might have had a few typos in here. We've changed a lot of code, right? Let's see if the program works at all. We'll try everything. Okay, so I think we've fixed everything? Question mark? Maybe not. Let's see. Run this code. So what do I want to do? I want to do a dance. Okay, that still works. I want to look around. Okay, that still works. Let's open the door. Okay, so we got a problem here. This is says local variable door is open referenced before assignment. So in line 61 here, it says return door is open. So we actually never saved this value, huh? Let's go check that out. Oh, I see. So let's go to line 61. I don't know what that is. It's right here and open the door, right? Open the chest. I'm sorry, let's scroll this way. Get the torch, open the door. Okay, so we return door is open. So right here it says if this door is unlocked, we say the door is locked, dang it. Let's make sure that door is open is false there. Okay. Let's make sure that we know the door is open here too. Okay, no big deal. We're gonna fix this all later, guys. I'm just gonna do a little quick hack to make that work. It's not really important to our code right now. But I have the same problem in another function later on. So let's open the door now. Okay, so the door is locked, dang it. That's fine. So let's open the chest. No, let's leave the cave. Let's leave the cave. Okay, so we can't leave because we don't have the key yet. That's why we beat the games right now. So let's open the chest. Let's get the torch first. Okay, we got the torch to look around, see if the torch is AWOL. Okay, the empty spot where the torch was, so that still works. Let's open the chest now. There's a key inside. Okay, let's open the chest again. Okay, so we got a problem here. Local variable chest is open is reference for assignment. Okay, so let's open the chest. We got a problem. Let me scroll this way. It's easier for you guys to see. All right, so we have, let's see here. This is what I just printed off. The chest is already open. There's a key inside. We have to write chest is open is true. And chest is open is true there too. Okay. There you go. Now let's open the chest. Let's open the chest again. It's already open. Okay, let's get the key. Okay, so player inventory is not defined. We have a problem here. And get the key. Here it says the player inventory.append key. It's not a thing anymore, right? We have to actually use the game state's inventory. So game state player inventory. Add the key to that. That's where it's at now. 2 turntables and a microphone. Alright, so let's run this code now. Open the chest. Get the key. Open the chest again. Should tell us that there's no key inside. Yeah, it's empty now. Okay. So now we can unlock the door. Okay. Oh, game state. Got a typo there. Game state is not defined. Let's go find out where that is. Let's find a typo here. Get the torch. Open the door. Okay, let's see. Here's the game state. Oh, it's probably down here, I'll bet you. Right down here. Get the torch. Open the door. No, game state. Game state. Where is... Oh, here it is. Unlock the door. Game state. There we go. Typos. Alright, so this should all work now, I think. Run the code again. Open the chest. Try to unlock the door before it's even opened. Oh, okay. So this is still a problem here. So unlock the door is a problem. Let's go check that out. It says return door is unlocked, which actually makes sure we got doors unlocked for everything. So let's just say door is unlocked equals true. Door is unlocked equals false, so they don't have the key, right? If they don't have the key, the door is still locked. Fine. Be that way. How about open the door? Same problem? No, open the door is fine. Okay, so run this now. Let's open the door. Let's unlock the door. Okay, don't have the key. Let's open the door. Door is locked. Let's open the chest. Let's try and get the key first. Get the key. You don't see a key. Okay, open the chest. Now we see a key. Get the key. Okay. Unlock the door. Okay, use the key. Let's unlock the door again. Unlock the door. It's already unlocked. Open the door, and then open the door. It's already open. Okay, now we can leave the cave. Okay, so now the program works completely. All the commands work and everything's fine. And we've made our functions a lot simpler, because now they all take the game state as their only argument. Right, so no longer do we have all these little arguments here, the varying arguments. They're all the same argument now, just a game state. Makes things a lot easier. But they don't all return the same value. Right, that's a problem. Because, as you can see, this, for instance, this open the door command, right? It returns the state of the door after the function runs. So if the door open is successful, now the door's game state is changed, right? The the door is open value changes from false to true. Right? If you open the door, then the door is open state of the game changes from false to true. And so what's happening is that we're returning this value. Right? Open the door returns a true or false value, and we're saving it into this game state. But we don't have to do that. We don't have to do that. I'll tell you why. I'll tell you why using an example. Let's make a new file here. We're going to save this as, mutability example.py. So before we talked about, defining, a simple function. And a simple function will take some argument, maybe another argument, right? And then it'll return some data, some data equals some argument plus another argument, right? And then it'll return that data. Right, so basically, a simple function will take in some arguments and return some data. That's true of any simple function. And let's run this function, right? Let's just run it. Let's just say, our output equals a simple function 1 and 2, right? So I return 3, right? We can print off our output, right? Cool. So let's run this code here. Mutability example dot py. All right, so it returns 3. I printed off 3. In fact, we actually skipped this output part. We can just put the we just print off the return value right here. Print off whatever a simple function returns with 1 and 2. All right, let's run this. There, 3, right? So you can actually just print off. So when it returns this value, it returns the value into the print statement, right? Print a simple function 1 and 2, right? It gives some value back, that's what gets printed off. But, this is a comment guy you guys learned last time that if we use this little hashtag or the pound sign or number sign, whatever you want to call it, before a line starts in Python, that makes the entire line be ignored by Python. We can actually type comments in there to make our code easier to read. So, simple functions always take data in and return data out. When we use object-oriented programming, however, functions may behave a little differently. Instead of spitting data out, they might instead alter some of the data that was fed in. Right? So instead of actually spitting out new data with return, it might just change some of your existing data. So let's give an example of that using a mutable, let's use a mutable data type as an argument, like a list. So let's just say, a list equals red, blue, yellow. Right? A list of color names. Right? So we're going to make a new function. Let's define a new function here. We're going to call this new function, an object-oriented function. And it's going to take in, some mutable object. Right. It's going to use its some mutable object. It's going to add something to that list. It's It's going to append green. No, let's append, something like, ice cream. Always add ice cream. Why not? Okay, so this function doesn't return any new data. It doesn't take this data, its argument, and then use it to make new data. It takes an argument and it changes that argument, right? Because that data is mutable, which means it can be mutated. It can be changed. So now we can say, I'm sorry. Let's run it. An object-oriented function. Take the list, click the mutable object, and then let's print off the new value of a list. Right. Let's see how this works now. Okay, so as you can see, after the function ran, the value of the list changed. So here we defined a list, right? It's got red, blue, and yellow in it. And then we supplied that list to this function. And this function did not return any new data. It just changed that list. And as you can see by printing that list here, that list has indeed changed. It had ice cream be added to it. In fact, we can even run it again, right? Let's print it there, and let's run it again. An object-oriented function, give it a list again, then print it off again. What do you guys think is going to happen here? If you guys are smart, you might already know. If you're like me, you probably don't. Boom! So you added ice cream again. So what this function does is it takes any list and it adds ice cream to it. Even if that list already has ice cream. It can do it unlimited time. It can keep doing it over and over again if we wanted to. It keep on adding ice cream to it. Which, why wouldn't you? But what's kind of profound about this is that, again, it does not return any data. In fact, up here, as you can see, we did this little simple print statement, right? This print statement will run a simple function, right? And it will print off the return data. It prints off 3, right? 1 and 2 is 3. It returns the addition, the sum of its arguments. So it prints off 3. But what if you print off? What if you do the same thing with this new function, right? What if we what if we printed this off, right? Print an object-oriented function, a list. What's going to happen? Probably you think it's going to print off red, blue, yellow ice cream. Let's find out. No, it doesn't. It prints off none. Well, that's confusing. Why does it print off none? We printed off the return value of an object-oriented function, a list. Right, so that's the argument, is a list. So this function, we explained, it takes in a mutable object, and it adds ice cream to it. Oh, well, there you go, right? It doesn't return anything. Right? It doesn't return nothing. It doesn't return anything. There's no return value. All it does is it changes the list. Nothing gets spit out of this function at all. It just changes something and then it's done. It doesn't actually return any data. That's why if you try and print off its return value, you get none. Because it doesn't actually return anything. But that doesn't mean it's not doing work. Some functions do stuff. They change stuff. They have a feature. They do something. But they don't actually return any data. And these are called object-oriented functions. Well, not really called that, but that's the principle of object-oriented programming, right? That not every function has to take data in and spit it out. Sometimes it just changes things. And that can cause some nasty bugs. Hey, what's up, Austin? How you doing, dude? That can cause some nasty bugs, guys. When you just sort of take data in and then you mess with it, you change it a little bit. That can cause unpredictability in your program if you get 10,000 lines of code or 100,000 lines of code, whatever. Eventually, you're going to be changing some data somewhere, and you're not sure where it happened or when it happened, and that'll cause some nasty bugs. So some programmers really prefer to use what's called functional programming, which means that every function always just takes data in and gives data out. Then it's very easy to find out where, how, and why your data is being manipulated. Whereas if you do more object-oriented style, there can be bugs that get caused by changing things. But I mentioned before that the reason why object-oriented programming is so popular is that it's very flexible and very easy on the programmer to use. And you have to every programmer has to compromise for themselves where the line lies between being convenient and being overly dangerous. So basically what we're looking at here, guys, is we kind of changed this function, right? We changed this list inside this function. Let's go back to our example and see how we can use that idea of an object-oriented approach to functions. How can we use that to make our adventure game better, or easier to program, I should say? Well, right now, some of these functions return new values for the game state. Right? They return new values for the game state, and then down here in our tree, for those functions, we have to actually save the game state manually right here. See, game state, adventures ongoing, is whatever the return value is of leave the cave. Fuck that! Fuck that. These functions already have the game state. We gave them the game state as an argument, and the game state is a mutable object. So instead of returning a value and saving it manually, why don't we just have the function itself update the game state? Mess with it. Right? We talked before about that can be kind of dangerous. Let's have it mess with it. Let's do it. So now instead of returning data, right, let's find all these functions that return data. Right here, open the chest. Right? It returns whether or not the chest is still open. Fuck that. Let's just change. Let's change it right now. Right? Let's say, instead of saying return chest is open, just say game state chest is open equals true. Just change it right here. Right? That simplifies our code a lot. No more return value. Do that down here too. Get the key. Right? It doesn't already have to. We already did that with get the key, right? Get the key already changes the game state right here. Right? So it's already doing some object-oriented stuff. Right here, return adventures ongoing. No, fuck that. No more return values. We're going to be object-oriented now. Right? So right here, we're just going to save it. Right here, we're just going to save this shit. We're going to say the game state that we got as our argument, update it. We have the game state. We can mess with it if we want to. Let's do it. And then right here, we'll get the torch. It already works that way, right? It's already object-oriented. We actually mess with the inventory right here. No return value. Get rid of the return value right here, too. Okay, open the door. Right? If the door is locked, then, the door has already been closed. You open the door, here's where things get changed, right? Change the game states. Door is unlocked value. No, door is open, excuse me. Change that to true. Now the door is open. Okay. And then, it's already open, that's fine, it's whatever. No more return values. Okay. I'm going to show you why this is important in a second, guys. Here's our last function here, right? Unlock the door. It returns a function, it returns a value, whether the door is still locked. Get rid of that. Here's where it changes. Use the key to unlock the door. Let's change the game state we were given. Just update it right here. Let's not rely on the code below to update the game state. Let's update it right here in the function. There you go. Okay, so now that none of our functions return any data, right, now they actually change the game state within the function itself, we can actually make our code a lot simpler again. We can actually get rid of all these return values, all these assignments. There you go. Look at how much easier it is to read now. So let's get rid of this right here, too. Get rid of this right here. And get rid of this right here. Okay. So now we've drastically changed the way our code works. We've been coding for about an hour today, kind of discussing, we kind of reviewed the way the code used to work. And now we've used dictionaries and mutability. Right? We've used some object-oriented concepts to make our code a lot more manageable. For one thing, all of our functions now take the same argument. Game state. Right? They all take the same argument now. They're all uniform. And secondly, none of them return any data. They just change the game state right inside of the function. So there's no more weird assignments going on here. It's all uniform. We just call the function and supply the game state. Call the function, assign the give them the game state. Right? Call a function, give them the game state every single time. So that's kind of cool. Now that means it becomes easier for us to write new functions in the future. We can actually make our game much more complex now, much faster, because we have an understanding of how every function should work. Right? They don't return data. They change the game state that they're given, and they read from the game state that they're given. Right? They all work the same way now. But what's extra cool is that we can actually use dictionaries to get rid of this whole logic tree. And here's what I mean by that. Let's say that one day our game has, 100 commands. Or not how many commands we have right now. We have like 1, 2, 3, 4, 5, 6, 7, 8 commands right now. Very simple game. One day it might have 100 or 200, 300 commands. So we're gonna have a very, very long list of elifs, right? Like it's gonna be a huge tower of elifs. Can we simplify this? Yes, we can, using dictionaries. Some of you smart guys that are watching on YouTube or here on Twitch might have already figured out that we have a situation here where dictionaries, that's what they're designed for. We're associating a string with something, right? We're associating a string with something. So we're saying if the player command is equivalent to look around, then run this function. If the player command is equivalent to do a dance, then do this function. If the player command is equivalent to open the chest, then do this function. Okay, so right away we're seeing that we're associating a string with a function. We're associating a string with a function. So why don't we, instead of doing this big elif tree, why don't we use a dictionary? So here we have our game state. Right, we're gonna make a new dictionary right now. We're gonna call this we'll call it like command map. Right? Making a dictionary here. And we're gonna map the term look around to our function look around. Okay? So this is something you guys have not seen before. You guys have never seen a function being used without being called. You guys usually see look around like this, right? You see it with parentheses and then arguments. Right? That will call the function. This will call the function. However, the function itself is a piece of data. So you can actually use that piece of data in all kinds of cool ways. You don't have to call it. You can rename it. Let's do a simple example. We'll call it, let's save this, and we're going to do a new script here. We're going to save this as first class functions. Right? We'll call this functions are first class objects. .py. What that means when I say that functions are first class objects, it means that functions, yeah, you can call them, but they're also data that can be moved around and manipulated. So we're going to make our own function here. We're going to define, a function. Could take some argument. It's going to print off, some argument plus was the argument. Right? It's going to print off whatever the argument was and tell you what that was the argument. Right, let's run our function here. We're going to say a function, O serif. Right, there you go. Some function O serif. Let's run it. Functions are first class objects .py. It says O serif was the argument, right? That's cool. But a function is also a piece of data. So we can also say, how about, some variable is equal to a function. Okay, now let's run some variable, David. Right, look at that. So it says David was the argument. So basically, we assigned a variable to the function, like a new name to the function, right? And we can call it by that name. Okay. We can put functions in a list, right? We can make it like, we can do define another function. It takes some other argument. And it prints off some other argument. Plus, was some other argument. Here's up, Kenny. Kenny didn't know this stuff. Kenny's a fucking pro programmer in Python. This guy's been doing Python for 8,000 years. He didn't even know that functions were first-class objects. He didn't know what the fuck that means. Right? He's just getting here. You're too late for the learning, Kenny. It's okay. You're still in time for the learning. All right. So not only are functions callable using this notation here, right? Where you supply the function name and then the parentheses. and then you give it an argument in between. But they're also objects, so you can assign them like any other object, like some variable equals a function. You can call it by that name too, and you can make a list of them. You can say, well, how about our list of functions equals a function and another function, right? We have both of our functions there, right? So we have a list of two functions now. We can call them both. We can say, for, one of our functions in our list of functions, just call it. We can call one of our functions and call it with argument, K-Rec Jr. There you go. It's a for loop. We haven't talked about for loops yet in this season. That was our last season. But let's just run it real quick here. We'll talk about that later. There, see? So K-Rec Jr. was the argument. K-Rec Jr. was some other argument. So we took a list of functions. I took a list of functions here, our two functions, and then we called both of them in a for loop with the same argument. So when I say that a function is a first-class object, what I mean is that not only are functions callable, but functions can be moved around. They can be manipulated. They can be renamed. They can be, used in a loop with, like a for loop like this. Basically, functions, on top of being callable, are also data. Right? We can supply these functions as long as you don't have these. So when you call a function, you use the parentheses. But when you're referring to a function, you don't. You just give it the name of the function. That's what I'm trying to get across here, guys. So let's use that as a part of our game to make our logic tree so much simpler. Let's go back to our Adventure Day 3 example. Right? So here we have something that's begging to be put into a dictionary. We have a string that's associated with a function. A string that's associated with a function. So let's just make this command map work. So here's our string, and there's our function. Let's just keep doing that for all of our strings. Do a dance points to a function called do a dance. Remember that? All right. Then we have open the chest is associated with a function open the chest. Let's break the line here. You guys remember the hanging indents, right? 1, 2, 3, 4. 1, 2, 3, 4 for the hanging indent. We don't have to go all the way to the far right of the screen. Okay, we have another command here. How about get the key? Points to a function called get the key. And then leave the cave. Points to a function. Leave the cave. And then we have, get the torch. I'm sorry, I mistyped leave the cave too. That points to a function called get the torch. But the command itself doesn't have underscores. The commands have spaces. That's what the user types in, right? Okay. And then we have, open the door is a command they might type in. That's associated with the function. Open the door. And then we have, unlock the door they might type in. That goes toward unlock the door. Okay. So, now we have this dictionary, otherwise referred to as a map. And it's called a map because the dictionaries will map a key, one piece of data, to another piece of data, in this case, a function. So now instead of using this big tree, this if, elif, 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 else tree, let's actually just comment this out. So I'm going to comment this out to make sure that Python ignores it. Right, we talked before about how Python will ignore lines that start with the pound sign, hashtag, number sign, etc. Right, so Python's going to ignore all that, all the entire tree. Now instead of this whole long tree, we can just use we're going to call a function here. We're going to call the command map, right? Whatever data was at player command, we're going to call this function using our game state. Kind of a bizarre looking line, right? But it works. Watch. I'm going to show you guys what it does here. Okay, run our Adventure Day 3 script. This is what you want to do. I want to look around. Holy shit. The cave is dank and there's a treasure chest. There's also a door. There's also a torch. So, instead of using this big if, else tree for logic, we just used a dictionary. It just did this and it made it work. Let's go over here and see if can I open the chest? Hell yeah, I can open the chest. Can I get the key? Right, of course I can get the key. It all works the same as it ever did. But how? If we're not comparing the command to a string and then executing the function, how is it working? Well, because the player command is a string, right? Whatever they typed in becomes a string. And that string is a key in this dictionary. Right? So if they typed in look around, then we say, the command map, what data is that look around? What value is that look around? Well, it's a function. So whatever's returned by that becomes, we call it, let's make it simpler. Let's make it simpler, make it easier to read. Let's say, our function. Right, let's just say, how about the command function equals the command map at the player command. So we get a function back, right? Then we can call that function using the argument game state. Right, is that easier to read now? So basically, the command map takes in a string, like a player command, and then it returns the value that string is associated with. So here, look around is associated with the function look around. So we save that as a command function, right? Command function is whatever is at the command map at that spot, right? At that value, at that key. Then we can call that function with the game state. And now you see why it's so important that all of our functions take the same argument. Right? Because now, no matter what they type in, whatever command they use, we know that the argument is the game state. So now we can just call the function the same way. And that's kind of if you're new to programming, it's kind of weird to get your head around, right? But that's why it's so important in programming to be able to slot things in and out equivalently. Right? So these functions all behave differently, but because they all take the same argument and return the same value, which is none, we can sort of swap them in and out for each other, like right here. It doesn't matter what the command function is. Whatever the hell we got out of our command map, we know it takes this argument, right? Because all of our functions take the same arguments. So because they're swappable like that, we can really simplify our code like nothing. Right? Boom. No more tree. A dictionary now. And as we add more commands to our game, all we got to do is add in more keys to the dictionary that point to a different function. Right? So we can keep defining functions, keep defining keys to those functions. Very, very simple. In our case, it's not always the case, but in our case, the function's named after the command too. That unlock the door points to unlock the door. It's kind of nice. Wow. But we have a problem now, guys. Can I undo? Is that thing I can do in Notepad? It is. Let me try a command like something we can't do yet. How about we try to, enter door. Enter the door. Right? We can't do that yet. We don't have that programmed in yet. What happens? It crashes the program. It says key error. It's a key error. Enter the door. So enter the door. That's what we typed in. It's a key. It's a key error. It's not a key. It's not a key in the command map. Right? The command map has a bunch of keys. The command map has a key for look around, and for do a dance, and for open the chest, and for get the key, etc. But it does not have a key for open the door. Excuse me, for enter the door. So we get a key error. We tried to feed the dictionary a key that it doesn't have. So it has no data to associate with that key, right? So it just has a key error that crashes our program. Whereas before, we used this tree, this big logic tree, right? Which was if, elif, then else. So else, in a tree like this, means if none of the above worked, then do this. right? So in this case, it was, if the player command is this, then do that, otherwise do that, etc., etc. And then finally ends with, if we didn't match any of the commands, then print you can't do that. Right? So before we had like a little fail-safe there that would keep the program from crashing. It would just say, listen, there's no command that matches that. You can't do that. But right now, our program crashes. We use a dictionary now. What can we do to fix that problem? Well, here's what we can do. We can use a trick we learned in Season 1 of Intro to Python. I'm going to reintroduce it here, which is a try block, a try except block. Now, what the hell is a try except block? Well, we learned about if blocks, right? If this is true, then execute the block. We learned about elif blocks. If the previous if was not true, and this next statement is true, then run this block. We know about while blocks, right? While this condition is true, then loop over this block. We learned about function calls, right? If this function is called, then run this block. As you guys know, a block is some indented code that will only run under a certain condition. So what is a try except block? Well, a try block, first of all, means try to do this thing. And if it crashes the program, don't crash, right? So basically, we're using the word try is to say, I'm not being forceful, right? When you run a command like this in any programming language, you're being forceful. Do this thing, motherfucker. Python, do this thing. Right? Obey me, you wicked machine. But if you use try, you're saying try to do it, but it's okay if you can't do it. Right? Try to do this thing. So here's where our program crashed before. We tried to feed this dictionary a key it did not have. Right? So that made the program crash. But hey, just try it. Just try to do this thing. Right? Try to do this thing. And then it has a follow-up block, right? It's kind of like how if can be followed by else or elif, right? So if this does not work, then do the other thing, right? Try is another kind of follow-up block, except. So it says try this thing, and if you crash, it's whatever. I accept that. Except, don't crash if you get a key error, right? So try this thing, but if you get a key error, then don't crash. Just print off, you can't do that. And that's true of any time your program crashes in Python. Right? Let me put this up here, actually. What's up, Ryan? Programming with Pythons. We're doing it, dude. We're doing it well. So we're saying now, try to use the player command as a key in the dictionary. And, if that works, then go ahead and run this game state. Run this function with the game state. But if you get a key error, don't crash. Just print off, you can't do that. Right? So try to do this. If you get a key error, then just print this off. That's what try except means. Let's see if this works now. I bet you it will. What do I want to do? Now I want to enter the door. It says you can't do that. Right? So basically it would have crashed because I just supplied this dictionary here with a key it does not have. But instead of crashing, the key error got accepted. And we ran this code instead. Print, you can't do that. Ryan says, oh no syntax highlighting. You're a brave man. Yeah, we're beginners here, Ryan. We're beginners here. We don't know what Vim is yet. We're all newbies. So we're using Notepad for today. But next Friday, guys, we're going to try a new program to write our code with. We're going to graduate away from Notepad to Idle, which is the program that comes with Python for writing Python. It's a bit easier on the eyes. A little bit easier on the eyes for sure. Okay, so we have made our code a lot simpler today. We've used some more advanced concepts, right? We have to understand more now, which can be tricky. But by understanding more about how Python works, we have actually reduced how many lines of code we have. Right? We have these functions on top now that all behave similarly to each other. They all take the same argument now, which is cool. And they don't return any data, which is cool. And our big logic tree, the if, elif, 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 has been replaced by this nice tidy little bit of code here. You know, we use this command map. Right? We've just mapped some strings to some functions. And now we can use that map to just execute what we want to execute, right? It's kind of cute. It works out pretty well. And now that means that all we got to do to make our game better is add new functions, maybe add some new variables to the game state, and add those commands to the map. We make our game pretty complex now very quickly, even though behind the scenes it's still as simple as it ever was. And that's kind of the goal when you're trying to do some programming in an elegant way. To be able to make the code work better and do more stuff, we'll have it still be as simple as possible for the person writing it or editing it in the future. Ryan says, many programmers just don't know how to get to making their own games, huh? Follow what he's doing here. You don't need to learn Unity to make a fun game. I totally agree, Ryan. It's kind of our goal here, is to prove that you don't need Unity. You don't need to have some crazy IDE. All you need is Notepad and a command prompt and, of course, Python. And then you're good to make some pretty cool games, I feel like. And speaking of which, guys, we have, about an hour left here to improve our game. I don't want to introduce any new concepts. I feel like we've already introduced some pretty complex ideas today. If you guys have any questions, let me know. Either here on Twitch or on YouTube in the comments. But let's just focus on using what we know right now, which is functions, simple block types like if and while and try except now, some dictionaries, some lists, and make our game a little bit more involved. Let's focus on some game design now, not so much on the Python side of things. Let's look at some game design here. So, for instance, we have a door and we have a torch in our game that are not being used yet. How about the first thing we do is make a function for entering the door. Right. So right now we can't really enter the door yet. We just explored that just now. Why don't we make a new function? We're gonna add it to our map here. Right. We're gonna have enter the door is the command, and we're gonna give it the function enter the door. But we don't have that function in our game yet, right? Let's add that right up here. So we have unlocked. Let's add a new function here. Def enter the door. Give it the game state, right? Every function takes the game state. And we'll say, if the game state, the door is open, then print off, you walk through the door. Right. So if the door is open, you can walk through it. Else, the door is closed. Print, you can't enter the door. It's closed. There you go. So we have a new command now, very simple. Doesn't really do much. So here goes, says, in the new generation, you can down parry Alex's back fierce. That's weird. That's really weird. Can you not toward parry it? You can down parry but not toward parry it? Because toward parry you think would catch it, right? So it's a hit grab. The whole point of it is to go through parries. Maybe it's a bug? Anyway, talking about third strike, Street Fighter 3 here. Okay, so we have a new function now, enter the door. Takes the game state, like all of our functions take the game state, right? And it uses the game state to see if the door is open. And if the door is open, you can walk through it, otherwise you can't. Let's see if this works. So we already added that to our command map, right? Sure we have. Cool. Let's see if it works. Let's kill the program that's already running with Control Pause on Windows. Then what you want to do, I want to enter the door. You cannot forward parry it, but I guess you can down parry. That's weird. Really, really weird. What do you want to do? Enter the door. So you can't enter the door. It's closed. Hey, it works. Let's open the door then, right? Open the door. Uh-oh, the door is locked. Fuck. Let's get the key. You don't see a key? Fuck. Let's open the chest. There's the key. Get the key. Can't open the door now. It's still locked. Let's unlock the door. Okay, use the key. All right, let's open the door now. Oops. Open the door. Okay, let's enter the door now. Hey, it works. Walk through the door, right? We didn't really, though. We can still look around. We're still in the same cave we ever were. Right? Because it just prints off data right now. It says you walk through the door, but it doesn't really change the game state at all. It just, you just walk through the door. It just prints off a message for you. But it works. Everything works fine. So now we can leave the cave, right? End the game. All right. Cool. But let's add a new variable to our game state. All right. So now, why don't we have a new variable here, the game state. We're going to actually add in a new one here called player position. And it starts off at cave entrance. Uh-oh. Uh-oh. It's getting a little bit sick now. So now, well, let's actually have to get rid of the underscore there. Just say, you are at the cave entrance. It's just a string anyway. So now you enter the door. What if it changes the game state? We're going to say game state, player position, right? Equals dark room. So now when you enter this door, your position is getting changed to the dark room. And now, if you look around, it'll change the message based on your position. So if game state player position is equivalent to cave entrance, then do all this stuff. Right? That's what the cave entrance looks like. Right? But if we say now, elif game state player position is equivalent to dark room. All right, cool. Well, first of all, let's say, if not torch in game state player inventory. If you don't have the torch, right? You don't have the torch. Wait, what? There we go. That's our problem. Didn't indent that all the way. So we don't have the torch to say, print off, it's too dark to see. All right? Otherwise, print off, strangely, you find that you're in a comfortable room. Right? You started off in a cave, now you're in a comfortable room. What's up, berries? Is there a switch on Python? Because you can prevent if, elif in a couple parts of your code. Yeah, you're right, berries. Yeah, there is no switch. Well, elif is kind of like the equivalent of switch in Python. It's kind of the equivalent of switch. But we've prevented elif in our code here by using a dictionary instead. We just got rid of our elif using a dictionary here. But yeah, switch case in Python is kind of replaced by if and elif in Python. Excuse me, switch case in like other languages. I've always wanted to try a text-based game where the game loop runs on its own thread. So you must be quick about entering text commands because the world is moving even when it breaks for standard input. Yes, exactly, Ryan. I've done that before myself. I've written MUDs before. If you want to play like an online text-based game, you have to actually have the world keep moving while you wait for input. You have to use a thread. JCP says, I have a project. Everybody wants to. What's your project, JCP? I can't imagine we would, but if it's something that needs help on in terms of some advice, maybe we can help out. If you need any advice, we might be able to help with that. Otherwise, we might demand some payment. Elephant, huh? Elephant. Like an elephant. Okay, so let's see here. So we're going back to our look around, right? So basically now, we have two rooms. And the way the game behaves differs depending on which room you're in. Right? The way look around behaves anyway, right? Look around behaves differently based on what room you're in. Let's see if this works now. Damn you, Ryan. All right, so let's see here. I want to enter the door. Okay, you can't. The door's closed. So let's, open the chest. Get the key. Unlock the door. Open the door. Enter the door. Okay, so I walk through the door. All right, let's look around now. Boom. It's too dark to see. All right, cool. That's what we wanted, right? Although we still got lots of bugs here, guys, but it's just what we wanted, right? So why don't we kill our program? Let's just leave the cave, right? We already have the key. Leave the cave. Okay, so let's run it again. Let's get the torch first of all. Get the torch. All right, now we can, open the chest. We can get the key. we can unlock the door, open the door, enter the door, and look around. So now we have the torch, right? Now we can see. So strangely, you find that you're in a comfortable room. Nice. Welcome aboard, Berries. Barry says, been here for less than 5 minutes and I fell in love with the way you speak. I'm sorry, Berries. I have that effect on people sometimes. You have to kind of pause the stream to kind of get your bearings back. I understand. I have the power of fairy to fascinate people. Not really. Okay, so we have some bugs though, guys. What's our bugs? Well, we entered the new room, right? We entered the new room, which is cool. But not all of our functions, in fact, only one function, look around, behaves differently based on what room we're in, right? If the player position is this, then do this, right? But every other one is the same no matter what room you're in, including open the chest, right? This works the same no matter what room you're in. So we can actually open the chest. We're in the wrong room, right? We can still open the chest, right? We're in the wrong room. We can still, get the torch, right? It's all. We can still get the key, right? It all works the same way, no matter what room you're in. So if we want to add more rooms to our game, we kind of have to go through each of these functions and add in this little if statement, right? If you're in this room, then do this. If you're in that room, then do that. Thank you for the follow, Barry's YT. Are you also a content creator, Barry? The YT makes me think you might be. Okay, so we want to make our game a little bit more involved. Part of that means that some of these commands have to behave differently based on what room you're in, right? So right away, I feel like one way to do that might be, oh guys, I feel like I'm going to blow some of your guys' minds here if you guys are new to programming. We're going to put a map in a map, a dictionary in a dictionary, right? So here's what we're going to do, guys. What we're going to do is we're going to, we have this command map, right? This command map maps every command in the game to a function. We defined that a little bit earlier. We talked about how this works earlier today. But what if we had different command maps for every room? Right, so we're going to call this, how about instead of calling command map, why don't we call it, cave entrance command map. All these work in the cave entrance. Right? And now we can make a new map. We'll call this, a dark room. I can't type for shit. Dark room command map. That's a dictionary. And it has look around in it. And for now, that points to look around, right? Because that behaves differently based on what room you're in. But all the other commands don't work anymore. These commands they're not recognized anymore, right? These commands don't work. And now we're going to make how about a room map, right? Let's call it a position map, right? And the position map will map the position of cave entrance to the command map, cave entrance command map, right? And then we can also map the position of dark room to the dark room command map. There you go. So Barry says, not anymore. I've started a job, and job in university takes all my time. I definitely know the struggle, dude. Being a content creator is very, very demanding. I can see why you have to put that on the back burner while you take care of more important business. Hopefully you can get back to it one day, though. What did you make, Barry's? Programming tutorials like this one, or maybe some gameplay, or maybe what, music? Just vlogging? Okay, so now we have we have 3 maps, right? 3 dictionaries. We have one dictionary that links all the cave entrance commands to their respective functions. One that maps all the dark room commands to their respective functions. And then a position map, which maps the name of your position, the cave entrance or the dark room, to the commands you can use in that area. Crazy, right? So it's kind of, we've got a lot of things that are now kind of like linked together. And now we can say this. Instead of just saying the command function is the command map, player command, we can actually say, function map well, let's just say, let's just say our command map, right? Our command map is going to be equal to the position map at whatever position we're at. So we're going to say, game state, player position, right? Let's make another variable, make it a little bit easier to read, right? Let's say current position is equal to the current game state's player position, right? And then we can say, the position map at the current position will give us our command map. So if our current position is the cave entrance, right? This gives us a cave entrance here. Then our command map is the position map at the cave entrance. That gives us back our cave entrance command map. All right, so now we have this as our commands we can use. Otherwise, if we're in the dark room, we get these commands we can use. All right? A little bit complicated here. So Barry says, I used to make gameplays and coding stuff. I mostly coded on stream since it was more fun than coding with no stream at all. You think so? I mostly code. I found that the coding streams I've done in the past haven't really been that successful. People don't seem to really care about that much. But I find that if I'm talking about why things work and how they work, it's a little bit more interesting for people, I think. Seems to be the case anyway. If I just sat here and programmed, I think people wouldn't find it to be that interesting. Okay, so now we have different commands we can use based on our position. And we use this dictionary here to associate the name of our position with the commands we can use. There's the name of our position and the commands we can use. And so here now, when we ask what you want to do, first of all, we figure out what commands we figure out what our position is, right? What's our position? Our position is saved here in the game state at the key player position. If we go back up here, we can see the game state. It starts off, player position is the cave entrance. Right, so we're going to get cave entrance here at first, as our current position. Then our command map we're going to use is the position map, and we're feeding it the key, a cave entrance. So our command map is going to be this. These are the moves we can use. The cave entrance command map. So that's right here. That's what we can use it at first. Then our function that we're actually going to be calling is what's in our command map. Right, we just find that right here. The command map at the player's command. Or the key to the player's command there. So we're going to say if we want to look around. Right? That gives us the look around function. And then we call that function finally with the game state as the argument. So up here, look around, for instance. Right, takes the game state as an argument. Then we can use that game state to read about, their position, or if they have the torch, that kind of thing. He goes, personally, I like the Battleship streams more than the teaching ones, huh? Happy to feel that way, here he goes. Again, our viewership for those was like 2 guys. One of them was you, and the other one was me. But I'm glad you got something out of it. I might go back to those someday, if only to finish Battleship. Maybe program some streaming utilities that would save me time after the stream. So one thing I do after the stream, guys, is I work on programming, stuff for the stream. That'd be kind of cool to do that on stream. Save me some time after the stream. Okay, so it's kind of cool. Let's see if it works. Let's see if now we have different commands based on what room we're in. That should be the idea, right? Now we should have different commands based on what room we're in. So let's go here. So now I'm in the cave entrance, right? Let's try and look around. All right, that still works. We didn't bug that out. And let's, do what we do, right? Let's get the torch. Let's open the chest. Get the key. Unlock the door. Open the door. And enter the door. Okay, so now we are in a new area. Okay, well, look around should still work, right? It worked before. Okay, so we're in a comfortable room now. All right? But now, what if we try to do a dance? That should fail. Right? Do a dance should fail because that's only in the cave entrance command map. Right? At the cave entrance, we can do a dance. But in the dark room, we can only look around. So let's see if this works. It's supposed to give us an error message back, right? Hey, it worked! You can't do that! Wow! Right? So our commands now change based on what room we're in. That's pretty neat. Right, so to do a dance, we should add that to our dark room command map, right? So you should be able to do a dance anywhere. Cool beans, bang. So now, when you type in a command, the first thing the game checks is what room you're in, or what position you're at. Right? You type in a command right here. Then it checks out what your position is. This actually doesn't need to be in the try loop. This is going to always work. So we know that try is there to catch an error message, right? So to catch an error, to keep the program from crashing. Let's paste that. Okay. Likewise, the command map here should be fine. There should be no crash there either. Don't bother putting that in the try. Okay. So, the first thing it does, you get the command from the player, right? Get the command. And then it figures out, well, first of all, where are you? What's your current position? So we check the game state. Check the game state for the player position. And save that as the current position. Then it says, okay, well, we know what position you're at. We know you're at the cave entrance or the dark room. So, what command map do we use? Right? Which commands do we have access to? So we use the position map, which is this. Its whole function as a dictionary is to map the name of the room that you're in to the command map you can use, right? Which command dictionary do you use to get your functions out? Okay, and then we try the command they typed in. We try the command they typed in. So if it causes a key error, they're trying something you can't do in that current dictionary they're in, because they're in this dictionary, they're in the darkroom command map dictionary. So if I try to open the chest, that'll cause a key error, because there is no key for open the chest in the darkroom command map. There is one in the cave entrance command map, right? But there's not one in the darkroom command map. That'll cause a key error. If we get that, the program will crash, except that we have this try block here. So it doesn't crash, it accepts key error. If it's a key error, it just prints off you can't do that. So now we effectively have different commands we can use based on what area we're in. Kind of fucking sick, actually. So, why don't we change the behavior of enter the door so you can go back and forth between the rooms? Right, let's give you guys an example here. If I were to run this program again, this game, let's just open the chest. We're going to get the key. Unlock the door, open the door, and enter the door. All right, I walk through the door. Now I can look around, but the problem is, it's too dark to see. I can't get the torch. Well, let's get the torch. I can't get the torch. It's in the other room. It's outside the door. It's in the cave entrance is where it's at. How do I get the torch now? I can't, guys. We soft lock the game, right? That's what that'd be called. If we were like game devs, if we were making games on, SNES or PlayStation or whatever, we soft lock the game. We didn't think about this. Now the game is over. We ruined it. Now we're going to have a lot of angry customers demanding their money back. So we can't enter the door, right? We can't enter the door yet. I can't do that because there is no enter the door command in the darkroom command map. So let's change that. Right? Enter the door is going to run enter the door. However, currently enter the door always sends us to the dark room. Right? It always sends us to the dark room. So why don't we change this now to say, hey, listen, if the door is open, then you walk through the door, right? But if game state, player position is equivalent to cave entrance, then change their position, to the dark room. Otherwise, else, if their position is not the cave entrance, then they're in the dark room, right? So now change their position back to the cave entrance. There you go. So now if they're in the dark room and they enter the door, they go back to the cave entrance. But if they're in the cave entrance, they enter the door, they go to the dark room. There you go. Let's try that. Okay, so we killed it there by using Control Pause on Windows, just end the program hard. Let's run the program again. Let's we have to open the chest first. Get the key, unlock the door, open the door, enter the door. Okay, you walk through the door. Let's look around. It's too dark to see. Let's enter the door. Hey, you walk through the door. Let's look around. We're back at the cave entrance. Sick. Get the torch, enter the door, Look around. There you go. So now we can actually walk back and forth through the door between our two positions and advance our game. We're not actually soft locked anymore if we enter the door before we get the torch. We can actually go back, get the torch, then go back into the dark room. And now we can see. Wow. So our game's getting pretty involved. You got a few different puzzles here now, right? You have to figure out how to open the door in the first place. You have to then get the torch to see in the dark room. But what happens now in the dark room, guys? What should we do? Here goes. Where does the game go from here? So we have a cave entrance that has a treasure chest with a key inside, and a locked door, and a torch. We can use the key to open the door. Beyond the door is a dark room. The torch lights it up. But what does the player do now? What's cool to find in this room? That's what I want to know. What's cool to find in this room? Well, some kind of cool item, you would think, right? What's a cool item that you can have? Where does this room lead? What's the point of this room? Maybe there's like a cool turntable in the room, right? Like a record player. We can find a record for it. But where do you find the record for it? Not in the cave entrance, you would think. That's already got some pretty cool items in it. We have to find another. We have to make another room. Right. So first of all, let's say that you're in a comfortable living room, right? When you look around, you're in a comfortable living room. We're in like a house inside this cave. Kind of bizarre. Right. So we need another room, basically. How about we have like a basement? Oh, that's creepy. A basement in a house in a cave? Is there anything creepier than a basement in a house that's in a cave? Let's print off, you see a door to the basement. Oh my god. But we can't have a door. We don't want to enter another door. How about we have like you see a staircase to the basement. How about that? We have like a descend staircase command, huh? Descend the staircase. Okay, see the staircase to the basement. Okay, so we have a basement now. Potentially. So why don't we... First of all, let's do something very simple, right? Why don't we make a new function called descend the staircase. Descend the staircase. Right, give it the game state like everything else we do. Then we can say, print, you descend the staircase, right? You descend the staircase. All right. Cool. Very simple. But now we have to change the way look around works, right? It's also have a feature for if you can look around the basement. So let's, let's say elif game state. If you're looking around, right? If the player position is the basement, then if you don't have a torch, you don't have a torch in your inventory, then print off, it's too dark to see. I'm knocking on heaven's door, right? Otherwise, if you do have the torch, print off, the basement is, the basement is, what? Moldy, right? The basement is moldy and smells ancient, right? How about we say it's too dark to see? Something stinks, right? Something stinks. It's moldy, smells ancient. Right? Print off, you see a shelf. You see a shelf with a record on it. Right? Say a vinyl record. Cool. Awesome. So if you're in the dark room now, you see a staircase. You also see a turntable. How about that, right? Print off, you know. You see an old record player in the corner. Cool. So now I have a record player in the living room of this weird little house. And we have a basement that has a record, vinyl record on it, right, on a shelf. Awesome. So now let's go to our descend staircase code. Down here, I feel like I'm missing a blank line. I guess I'm not, huh? Down here in our descend staircase code, it says you descend the staircase, right? But you actually don't change your position yet. Let's change that. So now let's say print, excuse me, let's just say game state player position is now being changed to, you know, the basement. There you go. Cool. It's now the way that you look around changes, right? We have to add a new command map too, right? Let's do a basement command map. All it has is look around right now. All I can do down there. I have to add that to our position map too. So let's just do like a, you know, basement. It's mapped to the basement command map. Easy. Awesome. Okay, so now we have a new room in our game, and because earlier in the stream we made all of our functions behave the same, they take the same game state, they don't return any data, they change the game state within their own little function like this, just manipulates it in an object-oriented kind of way. Because of that, we can simplify our code here. Remember, this used to be a big if-elif tree. But because of that, we can add entire new rooms to our game very simply by defining a new command map, mapping the name of the room to the command map, and then that's pretty much it. There's our new room, right? We have a new position you can actually explore in the game. Kind of cool, right? Before, if we had just stuck with our old way of doing things with no dictionaries, this would be a very complicated process of checking what room you're in, right? And then giving you different commands based on that room. That would have been a huge undertaking. But thankfully, with the use of dictionaries, aka maps, we can map data to other pieces of data in a way that really streamlines our code. We can very easily expand our code now. And again, that's really important. As you learn more about programming, you find that you get little shortcuts that can make your code much easier to grow. At first, you might feel like your experience is too limited to make complex programs work. But as we grow as programmers, you kind of learn how to take advantage of more complex ideas that seem harder to grasp at first, like dictionaries, right, and lists. They seemed like they were harder to understand at first than our simple variables of the past, our simple data types. But once you understand how they work, your whole code becomes simpler, which is kind of interesting, right? You take a relatively complex idea to make your overall code simpler. That's what we're doing here. Anyway, we have a new room. Let's go explore it. Right? We don't have a whole lot of stuff we can do there yet. Let's make sure that we haven't caused any bugs yet. Also, it's just fun to play our game. So we want to, open the chest, get the key, unlock the door, open the door, enter the door. It's too dark to see, right? That's okay, though. We can still descend the staircase. Descend the staircase. Oh, I can't do that. Oh, why can't I just do that? Did I typo something here? Oh, look at the darkroom command map. Doesn't have a command yet for descending the staircase. Okay, so let's fix that. Descend the staircase is mapped to a function. Descend the staircase. Okay, that's what it's called. Let's break this line here. Map it to the function. Descend the staircase. Okay. That'll work. Let's control pause to break to end the program. So let's what was it? Open the chest, get the key, unlock the door, open the door, enter the door. Now we can descend the staircase. We added the command, right? We had the function before, but we didn't have the command yet. Yeah, descend the staircase. Let's go. Let's look around. So I can't see anything, right? It's too dark to see. Something stinks. That was from up here, right? right? So that little line of text comes from here and look around. Our look around code changes based on our position, right? And if we're in the basement, if I don't have the torch, then it says, it's too dark to see. Something stinks. That's what happened right here, right? I don't have the torch. And once again, we soft locked our game, guys. If we look at our basement command map, these are the commands we can use in the basement. I scroll down. Here's the basement command map. So our commands we have access to in the basement are look around, and that's it. We cannot go back upstairs. So the game is soft locked now. We can't do anything else. You walk over to one side of the dark room. You find a staircase by accident and tumble to your demise. You died. Let's do that. That's a pretty good idea. I like that idea, right? It's a really cool idea. So the cave is the basement's too dark to see, right? But how about we change it so that if you try and descend the staircase, you can't if it's too dark, right? Right now, if it's too dark, you still can't see what's down there. Let's get rid of this code right here, for instance, right? So it says here, if not torch in the inventory in the basement, then you can smell the bad smell in the basement, right? But at least you got down there in the first place. Let's change this. You can't get down there now if it's too dark. So we can assume that the player has the torch if they're here in the basement. Right. So now let's go down to descend the staircase. This is where we're going to change the code at, right? We're going to use Kenny's suggestion here. So right now it says, descend the staircase. It says, you descend the staircase, and then change their position, right? Let's make that an if statement. If you have a torch in your inventory, right, then you can descend the staircase, right? Otherwise, print off, you walk over to one side of the dark room. You find a staircase and tumble to your demise. Print. You died. Then we're going to change the game state, right? Watch this. Game state. Adventure is ongoing. Becomes false. And as we know, if adventure is ongoing, everything becomes false. Right? If we scroll down here, our while loop that keeps the game running only keeps running while adventure is ongoing is true. Right? So once that becomes false, it stops asking what to do and goes right down to here. Game over. Let's try that. I think I might have typoed something in there, but let's try it. So let's end the game here. Control pause. That's the old soft lock version. Okay, so let's see what you want to do. I want to open the chest. I want to get the key. Unlock the door. Open the door. Enter the door. All right, let's look around. It's too dark to see. I don't have a torch yet. Let's descend the staircase. Boom. You walk over to one side of the dark room. You find a staircase and tumble to your demise. You died. Game over. That's it. The game's over. We're free. There you go. So we took Kenny's suggestion. It's kind of a cool suggestion. I like that idea, Kenny. So now you can't go downstairs if you don't have the torch. It's too dark to walk down the stairs, man. You fucking trip and die. But if you have the torch, you can go down there. Let's make sure that works still. So let's get the torch first of all. No, that's not actually. Let's open the chest. Right. Get the key. Unlock the door. Open the door. Enter the door. Now let's look around in here. It's too dark. Let's enter the door again. Now let's get the torch. Okay, enter the door again. There you go. Now let's look around. So now we can see. There's a staircase to the basement. Let's descend the stairs. Oh, I can't do that. Wait, my position got glitched out at some point? My position got glitched out, I think. Look around. Descend the stairs. Why can't I do that? Oh, a staircase. Wow, it's simple. I'm sorry. It's a staircase, not stairs. Descend the staircase. There you go. Okay, so now we can look around. Now you have a torch. Okay, cool stuff. So now if you try to go downstairs before you have the torch, you die. That's game over. That's in the true Zork tradition. Okay, so now we need to get the vinyl record, right? So let's add a new command to our command map in the basement. Get the record, right? It's going to point to a function. Let me actually make that line there. It's going to point to a function called get the record. Right? So now if you're in the basement, you can get the record. And let's add that function right now. Right here. Def get the record. Actually, I have to break a line right here too. There you go. Get the record. Let's give it the game state, of course. We're going to say if record in game state player inventory print you've already picked up the record. Then we're going to say else if it's not in the inventory print you pick up the vinyl record. Then we're going to say game state player inventory append record. We're going to give them a record. Kenny says, does the staircase deteriorate or can you walk back up? Not yet, we can't. Thanks for the reminder, Kenny. We can't go back upstairs yet. Let's add a new command. We're going to make a new command here in the basement. And we're going to say, how about ascend the staircase. I'm going to show you guys a cool trick after this, guys. I had a cool idea. So we got ascend staircase, and we're going to make a new function for that. Ascend the staircase, right? It's going to work the same way as descend. We're actually going to copy paste our code, actually. Let's not copy paste the code. Let's make a new function here. Def ascend the staircase. Give it the game state, of course. We're going to print off you ascend the staircase and change the position of the player, right? Make that back to dark room. Cool. Very simple function. So now we can go back upstairs. And again, because we're mindful of how we designed our code down here for how the functions are executed and how they're found and run, we can very easily add new functions. Can you believe that it was just as simple as adding in like 3 lines to let's go back to the previous room? That's kind of sick, right? Isn't that kind of crazy? That's because we were kind of mindful of how we designed things. All right, so let's run this code now and see if it works. Let's kill this code for now. That was soft locked. All right. Oh, I have a problem here. That's that our command mat looks like. It's a syntax error. I mistyped something. Right here. I have no comma there. Boom. There we go. You gotta separate all of your key value pairs by commas in the dictionary. All right. So let's run this now. All right. I'm gonna cave. I want to get the torch. Open the chest. Get the key. Unlock the door. Open the door. Enter the door. Okay. Now I want to look around. All right. Make sure I have the torch. I do. Okay. There's a record player in the corner. Let's descend the stairs. I can't do that. Oh, yeah. It's a staircase. Yeah. Descend the staircase. I'm sorry. Okay. Let's look around down here. Okay. There's a shelf. All right. Let's get the record. There's a bug here. Get the record. Okay. I got the record. Let's try it again. Get the record. You already have the record. All right. But here's a bug. Let's look around. If you look around, it says you see a shelf with a vinyl record on it. Let's fix that bug right now, right? Let's fix that bug. So we already have the record. If I look around, though, it says you see a shelf with a vinyl record on it. Okay, well, let's go back up here to our look around code. Right here. You see a shelf with a vinyl record on it. Let's just say if not record in game state player inventory, right? They don't have a record. Then say that. Otherwise, else, otherwise. So if they don't have the record yet, print off, or if they do have it, print off, you see an empty shelf. There you go. Okay, we fixed that bug. Let's carry on in our game here. So now what we want to do, we want to go back up the stairs. Let's ascend the staircase. Hey, it worked. Look around. Hey, we're back in the dark room. Nice. Let's descend the staircase. Okay, look around. Cool. Ascend the staircase. Nice. Sick. Let's enter the door now. And leave the cave. Game over. We walked out of the cave. We survived. Sick. Alright, so now we have a record now, right? We fixed our bug. About now you don't see the record on the shelf if you already have it. That's kind of cool. So now let's put the record on the record player, huh? So, previously, guys, we have always added items to our inventory. We've never actually taken items away. How do you do that? Well, let's put the record on the player and see what happens. So why don't we add a new command now for the dark room. All right, let's go down here. Here's the dark room command map. Right. Let's add a new command. Put the record on the record player. Right. Let's just make it simple. Let's call it listen to record. Right. And it points to a function we don't have yet. Listen to record. Let's program that function right now. I feel like the record should have some kind of hint on what to do next, right? But we haven't decided that yet. Let's just make it play music for now. We'll fix that later. So let's just say define. Thank you for the follow, Tech Guy WV. Welcome aboard, dude. If you have any questions, let me know. Pleasure having you. I'm David, by the way. Define a new function here called listen to record, or listen to the record, right? I think did I type that correctly down here? Let's see the base McMahon map. No, we have to say listen to the record, right? We're being kind of grammatically correct. In most games, you don't do that, but for our game, we do for now. Listen to the record. Okay, so listen to the record. It takes the game state as its only argument, like all of our, our game functions. And now let's say, if record in the game state's player inventory, then do something, right? Print off, mellow music fills the room. Right. Otherwise, print off, you don't have a record yet. You don't have a record to play. Cool. But here's the thing. I still have another bug too. That's all right. So let's just, for now, let's not worry about taking things out of the player inventory yet, because it's going to cause some bugs. Excuse me. I have to address that at a later date. For now, let's just see if the game works at all. We're going to assume that after you're done playing it, you take the record back and it stays in your inventory, right? Let's run our program again. You're in a cave. Well, let's get the torch. We need that, or else we're going to die. Let's open the chest we have in the entrance here. Get the key. Unlock the door. Open the door. Enter the door. Descend the staircase. Let's actually try and play the record player now. Let's listen to the record. Okay, I don't have a record to play yet. Okay. So let's descend the staircase. Let's get the record. Let's look around first. Okay. Look around. Okay, I can see the shelf with the vinyl record on it. Let's get the record. Okay, look around again. Now I see an empty shelf. Okay, that's good. Let's ascend the staircase and listen to the record. There you go. So we beat the game now, guys. That's as far as we can get. We got some cool music. Awesome. Let's enter the door again and leave the cave. There you go. Game over. So, before we start thinking about removing items from the inventory of the player, I want to address a problem our game has, a very major problem. We've been making kind of like a cute little example game. We've taken some assumptions, right, about how our game's going to be played. We were playing it as an example game for our stream. What if we were going to release this game? Well, right away we have an immediate problem. What you going to do? Go north. I can't do that. Pick up torch. I can't do that. Look around. Okay, well, there's a chest and a door and a torch. Okay, well, grab torch. I can't do that. Collect torch. Can't do that. It's a problem, right? We have to know the commands in advance. We have to know that get the torch is a command, right? So here's what we can do. Why don't we implement a new command called help? Oh my gosh, guys. We got new commands here. All right, let's go down here to our while loop, right? It says what you want to do. That's our prompt. And then we simply take whatever they punched in and try it against the available commands in that room, and then run the function based on that command, right? That's how our code works for now. But I want to do something kind of cool. Why don't we say if player command is equivalent to help, print, you have these commands available to you. Okay, that's kind of cool. And then we're going to say, I'm going to write the code and I'll explain it afterward. Let's say for command in command map dot keys print off 4 spaces plus command. We're going to call it command string. For command string in the command map dot keys print off the command string. Okay. Else do this. You know, run the actual command. So if they type anything aside from help, then just run the command. Okay, so just by adding in, what, like 4 lines of code, we have added a really cool new feature to our game. Let's see if it works. I'll explain how it works afterward. I think it should work just fine. So let's leave the cave. Oh, I don't have the key yet? All right, let's, oh yeah, I have to open the chest. Yeah. Get the key, and I can leave the cave. Okay, so now we can rerun our program, our new program. You're in a cave. Let me pick up torch. Can't do that. Let me collect torch. Okay. Help. Oh, look at that. You have these commands available to you. Look around, do a dance, open the chest, get the key, leave the cave, get the torch, open the door, unlock the door, and enter the door. Okay, well now I know what I can do, all right? Well, let's look around then. Okay, I can see that there's a treasure chest and a door and a torch. Okay, well, let's kick the chest open. Okay, can't do that. Well, fuck, let's help. What we got here? Oh, open the chest. Okay, open the chest. Gotcha. So you can see that'd be pretty helpful, right? Let's get the key, unlock the door, open the door, enter the door. Okay, so now we're in the dark room. Let's look around. It's too dark to see. Okay, well, let's enter the door again. Get the torch. Enter the door. Look around. So there's a record player, huh? Let's examine the record player. I can't do that. Well, help. Okay, so here I can look around, do a dance, enter the door, descend the staircase, and listen to the record. Oh, listen to the record. Okay. I don't have a record. Oh, I gotta find a record now. So now we have an actual game that works. We put in 4 lines of code, and now our game is actually playable. That's a problem we've had since the beginning. I've kind of been avoiding talking about that problem because we've been kind of using it more like an example here. I haven't really worried about the fact that a player might not know the commands because we're the only player, right? But in the future, we might not be the only player. So we've added this feature where now the player can see what commands are available in each room. Help. Now they can look around, get the record, and sense there. Okay, pretty simple. So how does that work? We haven't really talked much about for loops yet, right? That was our last season of Intro to Python. How does this help command work? It's only 4 lines, but it's pretty fucking cool how it works, right? Well, let's talk about that. So really, it's only 2 lines, right? This whole part with if player command equals help, you understand that, right? If they entered help as their player command, it runs this code block. Then it prints off a little cute statement here. You have these commands, but the real money shot is these 2 lines right here, this for loop. So how does it print off all the commands that are available in that room? Well, earlier we defined this command map variable. Right here we defined it. The command map is whatever command map is at our current position, right? It's a position map and our current position, right? So our current position is where the player is, right? It just simply reads the game state. It reads the game state to define what our position is. And then we use this position map at that position. So here's our position map, right? So if we're at the cave entrance, we get back the cave entrance command map. And that's being saved as our command map. So we have this command map. That's whatever we can do right now is our command map, right? And we're saying for command string in command map dot keys. What does that mean? What tells dot keys? Let's go look at our documentation for Python. This is at docs.python.org, guys. That's docs.python.org. Go to the library reference. Okay, got all the cool things we can read about in Python here. It tells us how to use some more advanced Python concepts. And look at our mapping types dictionary. What the hell does dot keys do? We talked briefly before in the last episode about what a dot means in Python. Let me read the chat here. Can I ask how to make a list of an item, but if you have made a web scraper? So I want to pull data from that list, and by random choose one of them, items from that list. Hell yeah, FC, we can do that right now. In a second here, actually. Welcome aboard, FC. I'm David, by the way. So we talked before about the append method. Let's go look at how append works. Right here. Listen to the, let's get the record, right? Get the record. So we have this inventory. Nice to meet you, FC. We have this inventory list. It's a list of data, right? And it has this append method. So we talked before about how in Python and other languages, a period implies ownership. Now in English, you use like an apostrophe S, right? Like, it'd be like this, right? Like, in English, it's like, ownership, like, David's record, right? The apostrophe S right there. Right? But in Python and other languages, it's a period. So we're saying the inventory list it owns this function, right? It actually owns this function, append. And we give it an argument of record, right? So what we're saying here is use this list's append function and give it this argument record. And we talked before about how if you have a function that's being owned by something, we call it a method, right? When I say a method, all I mean is a function that's owned by a certain object. So we have this append method. It's a function that is owned by this list, the inventory, right? So we're calling its append method, and what that does is it adds record to it, right? But here we can see how our dictionary has a method called keys. Let's scroll down a little bit here. Here's right here. Keys is actually owned by the dictionary. Returns a new view of the dictionary's keys. That doesn't mean anything to us. We're too much of a beginner anyway. We're too beginnerish. But basically what it does is that it returns a list of that dictionary's keys. Right? So here, I'm saying, if I typed in help, right? So get all the keys from that dictionary. So the keys are the commands, right? Right here. Look around is a key. Get the record is a key. Right? Get all the keys from that list. And then for every variable, for everything in that list, run this block. That's called a for loop. So you run a for loop on a list, and it goes through every item in that list, and it names that item this. So every item in that list gets named this temporarily. Right? So for every command string, we're calling it, in this list of keys, do this thing. Print off some blank space to indent it. Right? If I go over here, I can show you guys what the indent looks like. That's the blank space I added. So print off some blank space, and then print off command string. Right? And again, command string is every item in that list individually. So it does this for every item. It runs this code for every command string in that list. So that's what a for loop does. It goes through a list and it kind of iterates through it. It goes through each item and does a thing to it. That's kind of cool. I'm actually going to demonstrate that more in depth. In fact, I'm going to help my friend FC Node here now and talk about a little bit more about lists. Let's make a little extra notepad document here. Save it as, more about lists. .py. Little script. Still around, FC? hope I didn't bore you to death there talking about other stuff. So we're going to talk about lists, right? Let's make a list, right? Here's another list. Good stuff at FC. Here's another list, right? We're going to fill it with some random junk. We're going to fill it with, baseballs and, pocket lint. There's a bunch of garbage. How about, like, a smelly sock? Maybe, like, a old guitar. Just a bunch of nonsense. No, not yet, FC. I'm going to actually give you a more general example. Do a more general example here on how to kind of answer your first question about getting stuff out by random. So it's a random list, right? Let's say that, let's say that I want to get an item from this list at random. Right, let's just print off, let's print, another list at index 0. Right, we talked before a little bit about how lists, when you get data out of them, you don't use keys like with dictionaries. Instead, you use their index, which is their position. It starts off at 0. This is 1. This is 2. This is 3. So a 4-item list has, 4 positions starting at 0. So we're getting off the first item, right, which is index 0. Let's see what happens here. Let's kill this program here. Control pause. Let's run, let's just run Python, py more about lists.py. So it prints off baseball. Very simple. It prints off the first index. Gotcha. What if we wanted to have a random index get pulled out, though? So FC's question was, I want to pull data from that list and by random choose one of those items from that list. Okay, there's actually more than one way to do it. But we know we need some kind of randomness, right? So Python, by default, does not have any built-in randomness. There's no way to make anything random. Right? So let's just say, using, Python's built-in functions, there's no way to, let's say there's no built-in way to randomize anything. Right? No way to do it. However, Python comes with what's called a standard library. And that means that you can actually import new features into Python. Exactly, I've seen a random.choice, exactly. The lists don't have choice, I don't think, Kenny. They don't have choice. Random has choice. I believe Kenny's wrong about that. But what you can do is you can import random. So you have this library, you can bring in all kinds of cool features. Right? Where is it? I don't know where it is. Let's just find it. Control F. Random. So I have a library here, random. And if you import a library, welcome aboard, Tony James. It's actually called random here in Python. But you import a library, and then from that library, you can actually use all kinds of cool features that aren't actually in Python normally. Let's import random. That has all kinds of cool random features. Right up here at the top of our function, top of our program, that is. Import random. So now we can use all the features built into the random library. Let's see what it has. I'm going to show FC 2 ways to do it. Okay, so one way to do it is to use a random index. So let's see here. Randint, right? So randint is a method that will return a random number between blank and blank. Right? So we can actually go here, get a random thing by saying random.randint, a number between 0 and 3. Right? So it'll give us one of these indexes. Let's run this program right now. That's one way to do this, by using a random number as the index. Old guitar, smelly sock, pocket lint, baseball, smelly sock, pocket lint, right? So now it's random. So we can use a random index number to get random items from the list. Or we can more efficiently, more Pythonically, use a choice, which is what Kenny was talking about earlier. That's what Tony James is referring to, I think. We can use random.choice. We go look at what that is, right? Right here. Random.choice takes a sequence as an argument and returns a random element from the non-empty sequence, right? So let's try that. So instead of calling it a random integer as an index for the list, we can just call random.choice on the list itself. We give it a list, and it gives us a random choice from that list. Right. Random.choice, give it the list. We get some random stuff. That's a little bit simpler, a little bit easier to understand. Oh, I'm sorry, that's the wrong thing. This is the game. more about lists. Yeah, so I've got pocket lint, old guitar, baseball, pocket lint, smelly socks, pocket lint, baseball. You know, it's random now. So that's how you get a random thing from a list. Now, FC Node wants to give me this code, huh? But I feel like we don't really have time to look at your code, FC, and make it work for your code specifically. I hope that by showing us this example, you understand how to get a random thing from a list. Can I ask how to make a list of item? But if you have made a web scraper, that's a problem, FC. I think we're not really in a position to explain to you how web scrapers work. So I want to pull data from that list, and by random choice, choose one of them from the list. Yeah, if you have a list, FC, then you can use random.choice to get a random thing from that list, for sure. As for how to create the list, that might be beyond our scope right now. In fact, it's time for us to end the stream. It's 8:55 here, guys. We usually end the stream here at 9 o'clock for Python. Hope you enjoyed it today, guys. We actually had some pretty cool features added today, right? If we look at our code for today, let's actually open up our game. Adventure Day 3.py. We made some really good progress today. Yeah, thank you, Kenny. Yeah, if you guys are on Discord at Vencabot.com, go there and join our Discord server. You can ask me questions anytime. You can show me your code on GitHub. We can really walk through some more personalized examples on how to get your code working. But here on the stream, we try and focus more on really general stuff for the total beginner programmer. We don't really usually look at someone's code and try and make it work. It's kind of outside of our scope, I feel like. Thank you for the suggestion, Kenny. So today, guys, our game changed a lot. One thing we did, first of all, was took all of our functions and we made them uniform in the arguments they take and the data that they return. When we started today, all of our functions took a variety of arguments, and they all returned a variety of data. Now they all take the same argument, which is the game state, which is the dictionary, and they all return the same data, which is none. They return nothing. They just change the game state within the function itself. And we talked about why that can be dangerous, about object-oriented programming and how some programmers really prefer that all functions take very particular arguments and return very particular data, right? Because if you do what we're doing here, which is take in a whole bunch of data you don't even need most of the time, and then return nothing in particular by changing things inside, that can cause some major problems. Some key errors, something you're using what? A dictionaries node, not lists? A dictionary, perhaps? Again, if you're on our Discord server, FC, you can ask us more pointed questions, more particular questions. I can answer them when the stream's over here tonight. But yeah, so our functions now take the game state, the entire game state, which can be dangerous, and it changes things in that game state inside the function. It's at vencabot.com, FC. Just go to vencabot.com and you'll find it that way. Let me see if I can put it in the chat here real quick for you. That would be at http //vencabot.com. If you look below my stream, that one will actually work. Kenny's won't work because it needs the HTTP on there. Post your code on Intro to Python, FC. Intro to Python. But yeah, so our functions now take a uniform piece of data, and they can change the data in the function, which can be dangerous. That's not what you want to do all the time, but we're doing it for now. We're actually using the function itself to alter data. And they return the same value. Because they're all uniform now, all of our functions, we can actually use this code down here to compare the player's command, what they typed in, the string, to this dictionary, and get out that function. And because they all behave the same way, we can assume we can call that function like this, right? So that's a very streamlined way. It's a very streamlined way to get the command and then get the right function and then call that function and do some stuff, right? Another thing we changed today is we changed how the game state is saved in particular, right? Like the game state now, instead of being saved as a bunch of loose variables that have to be kind of supplied as arguments one at a time, we're putting all these game state ideas into this dictionary. You have a string, which is the name of the what we're saving, and then the data we're saving as the value. So the key and the value we're saving to that string. Right? So chest is open is false at first. Door is unlocked is false, right? Player inventory starts off as an empty list. See what I'm saying there? Then we have more dictionaries, which are the command maps, right? The map of the string, the command, to the function that it's called when you input that command. And we have one of these dictionaries for every room in the game, or every position. Hey, good night, Kenny. Thank you for stopping by, dude. Always a pleasure to have you in the chat, homeboy. Yeah, so every position has different commands you can use in that position. Right. Cool beans. So basically, our program now, it's much more flexible. It's much more easy to add complexity to it now than it was before. We can very easily add new rooms now. Each room has its own cool stuff you can do inside that room. You can go back and forth between them. We can add new commands very easily. No more of this if, elif thing. We just add a simple command, and then a command, and then a function. Right? Very, very simple. Kind of cool. I think we had a lot of cool progress today, guys. Next time, on next Friday, we program here every Friday. Next Friday, we're going to be using idle for one thing. No more notepad. We're going to put our big boy pants on and use idle now. It'll look a lot nicer, that's for sure. And we're going to look at more object-oriented programming, how to use classes, how to use methods, how to use attributes. And we're going to make our code even simpler that way, believe it or not. It's going to be much easier to add new rooms and new features once we start looking at classes. That'll be next week, guys. I'm going to go a very short break and come right back with some pizza and a movie. We're going to actually eat some dinner here and watch a movie together. If you're like me and maybe you want to help the channel out, you enjoy it a lot, but you're not really rolling in dough. You can help for free by getting in the chat, come say hi, like FC Node and K-Reg Jr. and all you guys coming by. Thank you so much for hanging out with me and making Python so much more fun. Also, you can follow on Twitch for free, tell your friends we're here, save clips, not really of programming probably, but of gameplay. We play a lot of games on this channel. And, if you've got a little bit of money in your pocket kicking around, you want to help the channel out, Patreon's great. I stream for 40 hours a week every week. It's a lot of work. And when the stream's over, I work on the stream all night long. It's kind of like my whole life, guys. So Patreon's really important to make the stream functional in the long term. Right now, we are nowhere near sustainability, financially speaking. So if you guys have any change kicking around or anything in your pocket you want to help out with, it's a huge help. Patreon.com/Vencabot. Even $1. It helps me buy food and groceries and gas, that kind of thing. Also, we're on YouTube, guys, at youtube.com/Vencabot Archive. That's youtube.com/Vencabot Archive. I have all my past streams archived there in 1080p, 60 frames, including lots more of Intro to Python. This is our second season, guys. Our first season was Pokemon. We actually started from scratch, and by the end of it, in 6 episodes, we had an entirely fully working Pokemon battle. You can add your own Pokemon, make your own Pokemon, define your own moves very easily in 6 episodes. This is our episode 3 of our second season. Where we're still kind of in the basics still. I'm sorry, guys. A little bit excited here about this pizza coming up here. Ugh. Also, we have a gameplay on there, all kinds of cool stuff. We'll go for a short break, guys. Come right back with some movies and pizza. I'll see you guys very shortly. I can't help it, guys. Pizza's on the way. It'll be here in like 15 minutes. I'm so excited. We're going to watch a movie called Scarlet Street here. Public domain. The public domain. Our game is so cool right now, dude. The game is working really well. Lots of Ken pressure here. Nice link.
Oh my god.
Oh my god. Oh, splash! Oh! That was fucking sick! Oh! Hey, good stuff. Here goes. Is it from a cup, or did you make it like for real, for real? No, here goes. It's alright, dude. You don't need to have pizza. Pizza's just symbolic of Din Din. Din Din comes in many shapes and sizes. Nice. I always feel like guys around my age, we should just eat garbage. Just microwavable garbage. I'm always surprised when other people like actually make food. Very early uppercut. Blows my mind. Ooh, nice. I like to dash up into the crouching short, try to fake him with a throw. Oh man, it's super! Get it! Got it! Yo, he's not mutant. He's got no meter left to work with! Still no meter. There you go. Oh! That's so sick! How can he break that grab? That's unbreakable. Oh! That was so sick!
Let's go, Rage!
What a re!
Oh my god.
Got an early Christmas gift, huh? That was, what a comeback. It's still weeks away, dude. Around it's like 2 weeks away, practically. People already giving you pots and pans and stuff?